Great. Okay, hi everybody. Thank you for that very kind welcome, Robin. Slightly undercut by the idea that, in fact, nobody from outside would come and give the talk, or that we'd forgotten to answer them, and so on. And also, the kind of, I mean, Robin and I are just across the corridor from each other, so we bump into each other quite often. Robin's office, I don't like to go in there, it's a bit sort of dark and dangerous looking, but we see each other quite often, and Robin invited me to do this rather along the lines that he just said, and I mean, I'm delighted to be doing it, but there's also something slightly sort of valedictory about it, which leaves me a bit uneasy, but maybe we'll that as we go along. So Robin wanted me to do something that was kind of reflective of some of the things that I thought about, I guess, at a broader scale or something of that sort. But I didn't want to do that just sort of reminiscing or trying to give a sort of a philosophical presentation. So I've tried to anchor this in a case study, or in a kind of a series of case studies that have, that I realize that I've come back and revisited from time to time. And it's with regard to those that I'm hoping to tell you a story about sinks, about carbon sinks and methane sinks. I hope to tell you a story about sinks, but also reflect in the process on the business of how it is that STS stands in relation to the things that we're analyzing and to people who might want to hear about the things that we're analyzing. So I think I'm going to try and keep this down to half an hour, so it's going to be quite rapid. If anybody's got any questions, you know, like they didn't understand that particular diagram or they want to see that map again, just put your hand up and I'll go back to it, because I don't want to be obscure about things. But I'm going to try to keep the pace up because I tend to go on too long. Okay, so it's introductory stuff. I've sort of done the introductory stuff. So the position of this paper, and as I say, what I want to do is to tell an STS story about my engagement with these topics at the same time as I want to give a story about sinks. And I've taken this, this is quite an old, this is 2004 from NASA Earth Observatory, but it's quite a nice image and one of the best ones that I could easily find on the internet, because it gives a sense of what we mean by sinks. So is it okay if I move? Right, yeah. So in a sense, you've got this big circle going around of how carbon passes through the entire Earth system, and then they're trying to put figures on, you know, how much carbon, for example, is dissolved by the oceans, and then how much is released back into the atmosphere. That's up here, and then how the dissolved carbon moves around the oceans in typical pathways. So this is what a sink is. For most greenhouse gases, there are sinks. Carbon dioxide is obviously the most important greenhouse gas for policy purposes, and natural sinks are very important for that. Methane is basically not really soluble in water, so the oceans don't play a big part in its uptake. It gets scavenged in the atmosphere in a way that I'll talk about in a bit. But what I want to do is to tell you a story about where I first came across, and I think a lot of people in STS first came across, the politics of sinks. Now, some of you may know this first story, and I apologize if you do, but a lot of people weren't even born when it happened, so they probably missed it, or they might have read about it, but they certainly weren't around for it. So I'm going to go into this one. So I think the first major story where people began to think not just about the importance of sinks, but there was a kind of active knowledge controversy about what do you do with sinks and how do you think about sinks, came about because of a publication of the World Resources Institute. So it was a report for 1990 that was actually published in 1991. You can access it on the web very easily if you want to. It's quite a big thing. It was almost like anticipation of an IPCC style report, attempt to synthesize environmental information, and had a big section on climate. So essentially what the World Resources Institute was doing was trying to think about, well, what kind of policy initiative do we want to have if we're going to do something about carbon dioxide and the greenhouse effect or global warming? And they came up with a strategy which was aimed at identifying the worst performing countries and shaming them by publicizing just how badly they were doing in terms of their carbon dioxide. So the aim was to come up with a sort of simple calculation of, who produces the most, and so that if you could trouble their governments and get them to do something, you could maybe do something for the benefit of the whole world. And of course, that was a different strategy to the one that was eventually adopted for Kyoto, where with the Kyoto Agreement and subsequently, what everybody tried to do was to get a target that everybody would sign up to. WRI said, no, let's not try and do that. Let's just try and work out who's worst, because some of the worst ones are really hugely bad, and if we could just get them to stop, well, we could pick up with, what Lithuania or something is doing afterwards. So what they did was try to work out how much carbon dioxide and methane and other greenhouse gases, but those were the main ones they were interested in, were produced by different countries. Now, there was a point about these sinks, which is that from the science that was available to them at the time, it seemed that there were important sinks which absorbed quite a bit of this carbon dioxide and methane that the countries emitted. So, for example, they say that about 56% of humanly produced carbon dioxide is absorbed by environmental sinks. So rather than going into the atmosphere and staying there, it goes into the atmosphere and is absorbed by plants or by oceans. The figure for methane is even higher, around 83%. And so what they did was essentially they gave everybody a rebate or a discount on their emissions. So nobody chose to have sinks, nobody chose that the oceans could dissolve carbon dioxide. So let's just apply this discount to everybody, and then we get the figures. Okay. So that was the kind of strategy they adopted. And this led them to come up with their top 10 countries. So they just said, this is, as it were, a policy advantage. Let's just work out who's worst, and then we can put pressure on them. Now, they set this out in terms of countries, but they also set it out in terms of countries and supranational entities, EU, because the EU was already beginning to think about environmental reporting as a bloc. So their top 10 worst were the United States, the Soviet Union, Brazil, China, India, Japan, the EU, Indonesia, Canada, and Mexico. Now everybody admitted this was a crude exercise. It was just trying to work out who was worst so we knew which governments to bother first.
That's presumably in order of level of pollution.
I beg your pardon?
That list is in order of...
Yes, I beg your pardon. Yes, this is in the order of emissions. And now this gave rise to, there were people who had concerns about exactly with the figures and whether this was the right kind of strategy to adopt. But there was a rebuttal that came from a couple of, it was published by a couple of Indian researchers at a center in Delhi that became very famous, and I'm not sure how much people will know this, but essentially they did a reanalysis of the same data and pushed back on the kind of implications that were in the WRI report. So they notice that of the top 10, and I tried to lay this out in a way that makes it clear. Funnily enough, 5 of them are industrialized economies, and 5 of them are developing economies, or would have been seen as less developed economies at the time, in around 1991. So they say they're concerned about the justice of this situation. And what the Ogawa and Narain, their principal argument is based around 2 things. So they become interested in, well, are all emissions the same? So do we, so the WRI do this, they count all the emissions. Well, they say, well, is that actually right? Should all emissions be treated the same? And secondly, they become very interested in this issue of sinks as a rebate on emissions. Now, the kind of emissions, I guess, is a fairly obvious target. If you had said, you know, do an STS kind of deconstruction of this, you might come up with the same kind of arguments as they did, which is that, well, breathing, I don't really have much choice if I'm going to breathe or not, and I produce carbon dioxide by breathing. So maybe that's a different kind of emission from if I choose to take a car, or if I have an SUV, or if I fly a lot. So there may be some question about discretion over emissions, and they try to make a distinction between sort of obligatory or necessary emissions and what they call luxury emissions. Now, you could do a lot more with that, but that's one of the lines they take, you know, saying, well, if there are things that you need to do to cook your food or produce your food, well, that's kind of closer to being a human right, and those emissions should be treated differently from other kinds of emissions. They also do the kind of other obvious things, which are to do with, you know, trying to come up with problems in the data that was recorded for the particular year. So Brazil does particularly badly in these figures, and that's partly because of the governmental initiative which allowed a lot of logging in the year in which these figures were generated. But the other thing they do is to look at the emissions. So only a fraction of carbon dioxide emitted, this is a quote from them, but they're quoting WRI, only a fraction of the carbon dioxide emitted during a year remains in the atmosphere. This amount totals 3.7 billion metric tons. This table apportions the total carbon increase to each country based on its share of the gross emissions of carbon dioxide. So the more you emit, the more your discount, as it were, is worth. And of course, Ogawa and Narain say, well, hang on, how about if we separate these 2 things? Okay, how about if you separate the emissions from the sinks? Because you're in charge of how much you emit, but you just got lucky in having the sinks. Okay, so, you know, it's not like America has ownership over a lot of the oceans and therefore has a right to the absorptive capacity of the oceans. So what Ogawa and Narain say is, okay, we accept your figures. They may be wrong. Let's accept your figures. We'll make a distinction between who emits, and then we'll take the absorptive capacity of the globe, and we won't allocate that to the people who emit most. What we'll do is we'll divide that up so that everybody in the world gets the same share. Okay? So, you know, we're just lucky that the world works in this way. Let's share that out democratically. So they rework the figures. They separate the emissions, which are attributable to whoever did them, from the sinks, which they allocate per person. And of course, the fact that these rebate figures are quite high means that there's a lot to play for in this. Because if you absorb if the world absorbs 83% of the methane, that's going to make a big differential between the amount that is individually emitted and who is responsible for the, or who gets the credit for the sink's absorptive capacity. So, you know, they say, for example, in order to back this up, you know, well, India has a lot, this is a a map that I took from the Indian embassy, so it probably has some contentious claims about what the boundaries are. Let's not go into that, okay? But I show this because, they say, well, India has a lot of coastline. So maybe India could make a big claim to the oceans because it has a lot of coastline. But they don't want to go that way. For the sake of this argument, they do it on the basis of individual. It's the patrimony of the world or the inheritance of the world, and we should share that out individually. Now, of course, what happens when you do that is the figures are vastly different. In fact, when they recalculate it, it turns out that Indian and Chinese people are net absorbers of carbon dioxide because each of them gets the right to a 6 billionth share of the world's absorptive capacities, and that happens to be more than the average Indian or Chinese citizen at the time emitted. So they say, we're not disputing your figures, we're just doing the allocation of the sinks in a different way, and it leads to a radically different outcome. So that it's not just that India becomes a smaller emitter, India becomes a net absorber of carbon dioxide on this basis. And sort of if everybody lived like an Indian person at that time, well, then the sinks would be able to absorb everything that's emitted. That's not quite right, but that's the kind of argument they make. So their claim is that the unfairness was kind of hidden in the assumptions that lay underneath the rather positivistic approach that the WRI adopted. The WRI said, we're just going to add up the figures. Oh, look, this is what happens with the sinks. We'll just allocate that. Nobody really knew about that. That was nobody's responsibility. We'll just allocate that per emission. If you do all this differently, it comes out with a radically different conclusions. So, of course, there have to be some assumptions. There is, these are human decisions about how you allocate the sinks, how you count the emissions. There have to be some assumptions that underlie that. But their point is that the assumptions that the WRI made were ethically and sort of politically exploitative because they didn't think about, well, doesn't the methodology that they adopt kind of reward the emitters by allocating the rebate in proportion to how much you emit? That's not a very good sort of economic incentive. Okay, so I don't know how many people know all about this. This was something I got very interested in about 30 years ago. And I thought this was a very, it's a kind of almost a classic controversy studies style thing, except the controversy is not so much about how people interpret different evidence or how they weigh different data. It's about how they analyze and think about the assumptions that inevitably underlie these things. The WRI get caught because they have they just think it's kind of obvious. They're doing the engineering mindset kind of question, kind of approach. The Agarwal and Narain explicitly attend to the sort of political, human rights, ethical aspects of this. Of course, in a way, they don't go very far with this because you could, even within India, you could say, well, how about men's emissions and women's emissions, or older people's emissions and younger people's emissions? There's a level at which they too universalize this in a way which is perhaps contentious. But at least, they make their point. Okay, so for me, I think that's one of the first sink controversies. And in part because of this controversy, but also because people realize that there is quite a lot to play for if 83% of methane is being scavenged and over 50% of carbon dioxide is being taken out of the atmosphere, additional is being taken out of the atmosphere each year by natural processes, people become more interested in sinks and how to treat them. So sinks grow in policy importance in the 1990s and the noughties. So you get, in the run-up to Kyoto, the first Kyoto Agreement, you get various policy initiatives that relate to this. So there was a thing invented called joint implementation. So joint implementation was about countries paying for carbon dioxide removal or improvement in other countries and then sharing the credits for the carbon dioxide reduction. So, for example, United States was saying, well, it's very, we built our power plants, we've got our transport system out. How about if we help developing countries to have less wasteful electricity power stations? Could we qualify for some of that carbon credit? And of course, after the Kyoto Agreement, you get this new terminology of, I've never known how to say this, LULUCF, which stands for land use changes and forestry. So it becomes a reporting requirement that countries report on their land use because, for example, different types of agriculture produce more or less nitrous oxide. And then land use changes. If you change the land use, well, that could either increase or diminish your greenhouse gas emissions. And then forestry, obviously, if you reforest, well, then that potentially gives you a carbon credit. If you do certain kinds of forestry that destroy the peat, well, then that doesn't. So people become interested in recording these things, and there is some kind of strategy around thinking about, well, maybe this is a policy tool, because Kyoto is basically about emissions reduction. It doesn't feature very much on sinks as a response. This is the United Nations chose this kind of image to talk about land use change and forestry. But the other thing that I think comes out during this period, which is interesting, and I think throws a kind of an interesting light on the first controversy between WRI and Agarwal and Narain, is that people start to actually do more detailed investigation of, well, what really happens with these sinks. So that the data which was in the WRI report, which Agarwal and Narain accepted, is admittedly rough. And so what happens during this period is that you get a lot of people, well, they're alert to the potential policy importance and the climate importance of sinks, but then they start investigating sinks. So are the figures correct? Does ocean absorption of carbon dioxide differ from one part of the ocean to another? So part of the question becomes, particularly around the Antarctic, where there are vast oceans and nobody is really sure about exactly what are the circumstances of absorption and ocean mixing at the Antarctic, because obviously there's the influence of the ice and the ice flows, and you have this kind of gyre going around the world. So there's a lot more interest in trying to find out what the sinks are, and you get new estimates of what the global level of the rebate is. So if you look at a textbook now, you don't get anything like the 56% rebate that the WRI had. The figures are much lower, because it seems that often the carbon doesn't stay in the oceans. It gets absorbed, but then it gets re-emitted rather quickly. But I think one of the things that I found most interesting about this is, of course, the claim that the sinks themselves and their capacity to act as sinks is affected by climate change. So as the oceans, we all know, I think, the story about as the oceans warm, there's more carbon dioxide, they potentially become more acidic, and we know about that problem, in terms of corals and so on. But I think less publicized is the idea that, well, sure, in 1991, this might be the rate at which the oceans were absorbing carbon dioxide, but the oceans are getting warmer. What does that do for their absorption of carbon dioxide? And it seems, by and large, that they become less efficient at absorbing carbon dioxide. But in a way, the thing that is interesting to me here from a kind of STS perspective is that, I had in the title the famous claim about the end of nature. So the idea, that if we have this vast experiment that we're conducting on the world where we're heating it up through all the carbon dioxide and other things we're emitting, in a sense, we've got rid of nature because, record temperatures don't really mean anything anymore because they're not, well, it's not within the natural variation. We've moved into this new situation at which we've sort of broken the bounds of nature. Now, what I'm kind of interested in is between the WRI and Agarwal and Narain, they were arguing about the principle of the allocation of sinks, but they weren't arguing about what happens to the sinks in the light of carbon change, of climate change. And so, in a way, I think this is kind of interesting from a SSK point of view, because often in controversy studies, we assume that the thing about which the controversy is stays the same, and there's a question about different perspectives on it. Just to choose something, I'm not presuming to compare this with any of the other things, but Steve Shaping's work on the constitution of the brain, the phrenologists and the surgeons trying to work out, well, what is the matter of the brain like? The presumption is the brain stays being what the brain is like, and they have different views about whether it's made of stretchy fibers or threads or whatever. Okay? But in this case, they're having an argument about what the nature of these absorptive capacities are and how they should be allocated. But at the same time, the world is kind of changing. So the controversy is ongoing, whilst the world that it purports to describe is not necessarily stationary. When I was thinking about this, I don't know how many of you know this famous old sort of philosophical thing about the Grue paradox. It's Goodman, isn't it? And the Grue paradox. So Goodman says, supposing, I've invented this new adjective, which is Grue, which are things which are green until a certain point in the future, at which point they become blue. Okay. Now, how would we know whether the things around us are green or Grue? Okay. And that feeds into the kind of finitist argument associated with Baron Barnes and so on. Now, the issue here is, in a sense, the world becomes Grue. So the people are having an argument over what the nature of the world is without noticing that the world itself is changing. That's not part of either of their arguments. Okay, they're talking about a stationary thing. And so it seems to me there's a kind of challenge through this period. Of course, at one level, these are all still claims about changes. Of course, one can handle it that way. But there is a kind of presumption within a lot of controversy studies that the thing which the argument is about is stationary, and the moving parts are the people's opinions and the controversy. Whereas in this case, I think one of the things that's interesting to reflect on is the extent to which, well, the very thing that they're purporting to argue about changes during the course of their argument. So how do we cope with that sort of reflexive or Grue-ish kind of component of the story? And just to be clear, Grue, in this sense, has nothing to do with the Minions. For people who are fans of the Minions, the master criminal is called Grue, but he spells his name differently from the adjective Grue. Okay, so the third part of my story relates to more recent period, and I've got a Scottish example, but there are others. Now, when we were doing the introductions, and also when Robin kind of was introducing me, I was at IASH, and then when I came back to STIS from IASH, I ended up getting this EPSRC award about industrial decarbonisation that Kyle and Mark are working with me on. That's been fantastic. My only kind of regret about it is that I had intended to be working on this, and I had begun developing a research proposal, but there was no way I could do it at the same time as doing the decarbonisation thing. So the third part of my story is something that I'm hoping to get back to soonish. Relates to the run-up to the Paris Agreement and continues to the present. So the Paris Agreement, people may remember that the Kyoto Agreement it essentially was an agreement for already industrialized countries. And then the idea was that there would be a Kyoto 2 into which other countries joined. But that didn't work out, and then there was essentially all the negotiations leading up to the Paris Agreement of 2015, which did a kind of, which kind of tried to repair the damage of not having a Kyoto 2, but the design was rather different. And during this period, of course, one of the things that people are aware of is that you get the potential to not only reduce your emissions and do joint implementation and that kind of thing, intervene in other countries and claim some of the credit, but that you can also do much more about managing your sinks so that you get credit for those absorptions. Even if you do the Agarwal and Narain thing and say, well, you know, they should be allocated on the basis of human right, which has never really worked with the UNFCCC. But even if you did that, if you do other things to improve your absorptive capacity, well, then surely you should claim the reward for that. You know, if you choose to plant forests, or if you choose to cultivate your countryside in a way that absorbs more, well, you don't want to share that with everybody else. You want to be able to privately benefit from that policy initiative. So carbon sinks become something that you can deploy or manage as part of your portfolio of your climate performance. And of course, the Paris Agreement operates rather differently from Kyoto in that the Paris Agreement has these things, they're now called NDCs. Before Paris was signed, they were called INDCs, and I quite like that because the INDCs stood for intended nationally determined contributions. Okay, so the new thing about Paris is that countries, it's not like Kyoto where you hash out the agreement and then everybody says, okay, I'll do the 7% reduction. The Paris Agreement is people make their own best offers. It's a bit like buying a house in Edinburgh. You make your best offer and then you go with that. So different countries may offer different things as their nationally determined contributions. But of course, the fact that you can do it in this kind of portfolio way means that people who have difficulty reducing the emissions or who want to still grow their economies in a way they think needs fossil fuels become very interested in saying, well, how can we offset that by doing things about our sinks? So we've got here, you can probably just see a thing that looks a bit like a butterfly. So this is a map of Scotland, and this is Scotland's territorial waters. And within this are plotted here carbon storage and sequestration, sorry, didn't say that very well, carbon storage and sequestration on biogenic reefs. So one of the things they've become interested in is finding where are Scottish reefs that could be encouraged to grow or managed in a way that there would be more Scottish absorption of carbon dioxide and other of carbon on these reefs. So one of the things that, and I'll show you the next slide. So this is carbon sequestration. So again, for Scotland, so this is the carbon store. Most of the carbon is inorganic. The purple is the organic carbon. But carbon sequestration on a year-by-year basis is overwhelmingly organic. So the thing that you can do something about is the organic carbon. And so this leads to not only an interest in emissions as a policy, but it leads to a big interest in marine science as a way of understanding the processes of that sequestration. So blue carbon suddenly, I mean, this is from a parliamentary report Scottish parliamentary report on blue carbon. Blue carbon suddenly becomes very interesting because this is something that now, you don't want to have this Agarwal and Narain attitude of it being the common inheritance of whole of humanity. This is Scottish sequestration, right? And you want to understand the exact mechanisms by which the carbon is sequestered in Scottish waters. And I just finish with one thing, that of course, this, as it were, surprising importance of marine resources, because obviously Scotland's quite a big country for the number of people that live here, but if you look at the territorial waters, well, they're bigger still. So if you can do something good about that, that's great for your carbon dioxide potential. Carbon absorption potential. So that you get this sense in which countries become much more interested in not only understanding and claiming, but extending or maximizing their claims for their territorial waters. You want to extend those claims and maximize them from fisheries benefits and prospecting and so on. But also now you have this kind of carbon or climate incentive to work out. And of course, one of the recursive things is, I guess we all know the stories about, in the north of Russia as the Arctic ice recedes, well, suddenly there are new places where people want to go and claim, well, that is part of Russia because, it's actually part of the continental shelf that actually curls out up into the Arctic Circle. So you get this kind of iterative process of, it becomes more important for carbon sequestration, and then you want to have more of your land, and the research that you do to investigate the carbon sequestration also becomes part of your claims to this being continental shelf and therefore part of your property. And you get, in that sense, a kind of co-production. I don't know if people know this. There's a nice interview, nice, with a slight irony, interview in which Sheila Jasanoff is talking about co-production, and she's kind of annoyed about people taking up the term and using it, as it were, wrongly, because a lot of people use co-production when they mean, I'm producing this knowledge with somebody else. And she says, no, I don't mean a kind of Hollywood co-production where, Brad Pitt did part of it and I did some of it. Brad Pitt's bad choice, sorry. Margot Robbie did some of it. And I did something else much better, stick with Barbie. But she says it's co-production where science and politics are made at the same time. And I think this is a very interesting example of, you claim your territorial waters and you claim the carbon sequestration, and you do science in the context of doing both those things. So it's the production of political realities and knowledge at the same time. Okay, that takes me to my final slide. So I hope you've enjoyed this story a little bit. I've tried to give you an STS story and a story of sinks. I think the story of sinks is more straightforward. So we started off with arguments about rights to natural sinks. So how do we allocate these? And Agarwal and Narain's brilliance was to see that you could construe these things as a human right rather than just as a fact about the natural world. Then sinks become investigated, and we have this recursive element that sinks change with climate change. So we're not just investigating a world, we're investigating a changing world, and you get into the kind of Anthropocene kind of arguments there. But more recently, and partly in result of the Paris architecture, you get this incentive to make research and manage our sinks. So we're not now any interested in universalizing the rights to sinks. We're trying to think about, well, what are the Scottish sinks and what can we do to make our Scottish sinks perform as well as possible. I think, therefore, that this was also an STIS story because it was a story about a controversy study, one that I thought was really, at the time I thought was interesting. But we also get this question of the kind of GRU element of thinking about, well, what do we do when we're looking at a controversy where the underlying reality isn't constant, but is itself changing and kind of outflanks the claims of the participants in the controversy. And then finally, once you've got this idea of making, researching, and managing our sinks, you get more into a co-production where politics and science are being done simultaneously. I think I'll leave it at that. Thank you very much, Robin.